Hello, welcome. This is my conclusion. That's my name. That's my ID number. That's the circuit that we've used for our project. We have the PIC18 here in the middle. We have the 3/7 segment displays. We have 4 LEDs. These two on the right here are for the doors. This one's the door lock. This one's the door open. We have these two. This one's for the temperature control system. This one is for the voltage control system. We have a voltage divider here for the ADC. That gives us a 1 volt reference for these temperature sensors. That increases the precision of them. We have 3 here. We could have more. We could have less. Our code is like very flexible in regards to that. So we have 3 here for the demonstration. We have the voltage supply system here. Like, this is what we are monitoring to determine if the voltage is adequate for the system. And we also have this button here, connect to port B on the interrupt. This is what we use to reset the EEPROM, just a button with a pull-up resistor. Next, we are looking at the UML activity diagrams. This is the main one for our system. Like, we start here. When the system turns on, we check if this is the first time the system is being turned on or not. If it is the first time, we're going to run this function. That's the first time setup. That's explained down here. So what's going to happen is we're going to ask the admin to type his PIN, then how many numbers, the number of users, then a PIN for each of those, and then we can ask him to change the settings menu, whether he wants it or not. And then if it's not the first time turning on, we can just read the EEPROM immediately after that and get all the information we need from that. And then we'll just be stuck on an infinite loop here where we call the voltage monitor function. That's this one. So we measure the supply voltage, we determine if it's adequate or not, and then we turn on or off the control system. And then we call the terminal interface control function. This function just outputs the voltage and measurement temperatures to the terminal, and then it'll see if the door is waiting for user input for a PIN or not. If it's locked or unlocked, it's just going to tell the user for how long the door is locked or open for, and it's going to continue. But if it's waiting for a PIN, it'll ask for a PIN, and then we'll see if the PIN is incorrect, in which case it'll lock the door. If it is correct, in which it'll unlock the door. Or if it's the admin, that's the special case. If it is the admin, it'll ask the admin for if he wants to use the settings menu. If he does, he will use it. If not, then just unlock the door. And while this is happening, we also have an interrupt. We have the timer interrupt. So every 1 second, it's going to trigger this. We're going to reset it, so it triggers the next second after. It's going to increment the seconds count. So this value is going to change once per second. And then if enough seconds have passed, so if long enough between measurements has gone by, then we will measure the temperature on the sensors. If not, then we'll just ignore that. And then anyway, we'll still display the temperature on the 7-segment display. If the interrupt was instead triggered by the hardware interrupt, so on port B, we will reset the EEPROM. That's the button that we have to reset the EEPROM. That's it. So now for the software bit, we start off by including all of the libraries that we need and all those things. We declare a lot of variables that are used for constants and that sort of stuff. So the door unlock delay time, the voltage threshold, temperature measurements, all that stuff. Some memory locations on the EEPROM here. Then we define some more variables. These are like miscellaneous variables, index variables up here, that sort of thing. We declare the function prototypes. Here we're declaring the temperature data struct. This is a struct we've made to make temperature measurements easier, because we wanted to give the ability to have multiple temperature sensors. We have this struct here, one per temperature sensor. In it we have the channel for that sensor specifically. We have measurement records from the previous measurements. We have the temperature average, the current average. We also have an initializer function for this struct, where we take in a channel and then we initialize these structs. Here we're defining 3 structs. We're defining 3 because we have 3 temperature sensors. If we had 4, we could just add another line here and then change that 3 to a 4, and that will work just fine. Here is the interrupt routine. So when it starts, we check if the interrupt subroutine was triggered by timer 0. If it was, we'll do this bit of code here. So we're gonna reset the timer so it triggers the next second after this. We're gonna decrease the door timer, so decrease it once per second. If it's 0, don't do anything, but if it's not, then decrease it. And then we're gonna increment the seconds count. This is like our main counting variable. So this is what we use to keep track of time in our code. Then if that variable is, if enough time has passed between temperature measurements, then we will measure the temperature. If not, then don't measure it yet. And then display the measured temperature on the 7-segment display. Also, if the temperature is higher than the threshold, activate the thermal system, otherwise don't. And then here, this is the big if instead of the timer 0 triggering the interrupt, the hardware interrupt triggered it, then just clear the EEPROM here. It's a for loop that goes through each position of the EEPROM and writes 0 to it. Then here we have the main. In the main we open the ADC with all these parameters, then the useart, and then we initialize the 3 temperature structs that we had. So each of them is initialized to a different ADC channel, and then we create an array of pointers to those structs so that we can use them later. This variable here keeps track of the size. We don't need to change anything. We just, if we had a 4th one, we would just add another line here. Then we initialize all of the ports for the pick. We initialize the interrupts and the timer 0, and we initialize it to 1 second again. Then we just lock the door and we continue. So immediately after that, still in the main, we check if the memory, if the value stored at the EEPROM memory location 0 is 0. That's where we keep the number of users on the program. So if it's 0, that means no users. There's no users in the program, so we need, it's the first time that the system has been turned on. So we call the first time setup function. Otherwise, if it's anything else, then we just read the values from the EEPROM that we had stored previously. After that's done, we go into this infinite while loop where we monitor the voltage and we control the terminal interface. Then starting on the functions, we have here 3 functions that are to do with the temperature measurements. We have the temperature average, so it takes in a temperature struct pointer and it goes through all of the previous measurements. It moves them by 1, so you can add a new measurement here. We measure temperature once, we add it to the record. Now we can reset the temperature average to 0 and then add all of the values in the temperature record here and then divide them by the number of measurements. That gives us the average. This function here, this is a temperature measurement. This is the one we call up here to get the current temperature. We call it with an ADC channel as a parameter. We get the measurement and we send it back. And here we have the display the temperature to the 7-segment display. So we pass in the temperature value here, and then we convert it to digits, and then we output them to the ports that we're using. Here we're doing some binary arithmetic, but that's just like masking some of the bits because we're using the same port as we're using for the useart, and we don't want to mix the outputs, so we're just masking some of the bits.